Good afternoon, colleague. My goals now. Show a way to detect weak LERN reactions that are difficult to track with conventional methods. Pay attention to the fact that LERN reaction may be nearby, where we do not expect. The detector is a thin layer of soot deposited on a DVD disc. Soot particles move easily, leaving a clearly visible mark. For clear detection of soot shifts, a magnification of 60 times is enough. LERN reactors scratch smooth surfaces at a distance of up to 30 centimeters for an unknown reason. Microscopic tracks up to several millimeters long are formed on glass, plastic, and metal, which was detected by Urutskoyev, Jigalov, Davia, Pork, Prim, and other researchers. In most cases, the tracks look like traces of a rolling grain of sand. After the LENR reactor is turned off, it continues to emit strange radiation for years, but the intensity decreases over time, which was detected by Jigalov and Chizhov. Hydrogen is contained in many LEN reactors. It's found in water or inside metal, such as nickel. The LENR effect occurs when a substance is heated or as a result of an electrical breakdown in this substance. A spark plug feeds for use approximately 60,000 kilometers. Breakdown voltage from 20 to 60 kilovolt. The current strength is approximately several milliamperes. Internal combustion engines meet this criteria and can also be LERN reactor. LERN process should be more active in the spark gap and in the spark plugs. To test the hypothesis, all used spark plugs of different freshness were collected from car service station. If a LERN reaction really takes place inside the combustion chamber, then the used spark plugs would emit strange radiation. Low activity can be compensated by the number of spark plugs and by the duration of the experiment. Many researchers recommended to use clean DVDs as detectors of strange radiation. In the first experiment, 30 spark plugs were placed next to a DVD disc for a week. Microscopic tracks were found on the surface of DVDs, consisting of repeated damaged chains. There were no tracks on the control DVDs. According to Jigalov, it is impossible to explain such a phenomenon by anything other than the rolling solid particle measured in microns on the surface of the material. To determine the agent what causes damage to the DVD surface, on article damage was caused by various mechanical methods: wire, sand, diamond dust, room dust. Identical tracks were obtained by slightly rubbing two discs against each other, covering with room dust what had been accumulated during a week. Near LEN reactors, an unknown force pressed random particles of aerosol into the disc for some time with a thrust of about 1 gram, which corresponds to 0.01 Newton. To make a drag appear, it's necessary that at the moment of the occurrence of an unknown force, a particle of solid aerosol lies nearby. Therefore, most occurrences on an unknown force near the LENR are not reflected as damages on DVDs. The sensitivity can be increased by coating the DVD with a layer that is more sensibility to deformation, for example, a thin layer of soot. To take a track appear it is necessary that at the moment of the occurrence of to retest the first experiment, 200 used spark plugs were applied to the discs with soot. The distance between the discs and spark plugs was about 10 millimeters. Expose time a week. On DVDs with soot, which had been laying for a week under 200 non-working spark plugs, a huge number of tracks were found. The tracks area occupied approximately 30% of the disc surface. The first type is thin lines, cleaned out of soot. Left photomagnification 60 times, right photomagnification 600 times. The width of most tracks is between 0.03 mm and 0.05 mm. The length of most tracks is from 0.1 mm to 2 mm. Tracks are arranged in groups. Track groups form large groups. Individual tracks are rare. It looks like some forms collected soot with a certain limit and then jumps and starts the process again and repeats it many times. In some cases, the tracks are bent, divided. The second type of tracks is much rarer than the first one. The second type represents sticking together tree-like branches, substructures. Magnification on the photo is 60 times. The length of the tree structure is usually 0.2 to 1 millimeter. There may be several branches. Left photomagnification 60 times, right photomagnification 600 times. The third type of tracks is very interesting. They are wide and relatively long, up to several millimeters, loose tracks. They are also single and 2 or 3 side-by-side tracks. In the case of 3 side-by-side tracks, usually the central track is wider, and those on the sides partially repeat each other. There is also an impression that the central wide track is formed from several thinner tracks merged together. The distance between the far tracks in one group is usually about 1 millimeter. In the next experiment, clean disc without soot, they place it near the car. The discs were in plastic containers and did not touch the car's aggregates. DVDs were placed above a running car engine, above a car electric generator, above a battery, inside a car, under a car, near the reservoir, and right after the exhaust pipe. The engine was idling for 3 hours. In this experiment, the tracks were traces from dust particles. The particles were pressed against the disc by an unknown force and moved across the disc, leaving from long lines of dust behind them. Tracks were found on the DVDs above the engine and near the exhaust pipe. No tracks were found on the other DVDs. Is it so easy to make dust particles create such traces? Could such traces be made by an ordinary airflow? After experiment, lumps of dust and other debris remained on the discs. Then the discs were well down by a fan and the garbage was blown away. Small particles of dust held very tightly to the surface. No new tracks were detected. Tracks were found on the DVDs near the exhaust pipe disc. Here we have dotted tracks. Conclusions. Spent spark plugs in a non-working condition give tracks on DVDs similar to tracks of the LENR. Near LENR reactors, an unknown force pressed solid microparticle of random aerosol into the discs for some time with a thrust of about 1 gram, which stands for 0.01 Newton. Most occurrences of an unknown force near the LENR are not reflected as damage on DVDs, where sensitivity can be increased by coating DVDs with a thin layer of soot. Tracks were found on the DVDs above the running engine and near the exhaust pipe. No tracks were found on the DVDs located inside a car. However, the purity of the experiment and statistics are insufficient to draw a clear conclusion about the presence of LENR in engine. More complete studies of this issue are of a great relevance, since more than 1 billion internal combustion engines are used daily in the world. They are located near people, and the effect of LENR strange radiation and other outcomes on human health is not fully known. Thank you for attention.
Thank you for the very interesting talk. We have a question, please, or a comment?
Yes, Oleksii, дякую for your presentation. Short question, what is the thickness of the soot layer that you use?
You can speak on Ukrainian or Russian, but my English not enough good.
Vladimir, are you...
The same, but all other don't understand.
This thin of layer of soot visually, it's very thin layer. Then not good enough we can see what after this layer then stop.
And another question, what's about that solid particles that rolling or sliding above the material? Did you see these particles or not?
Yes, in some case I see this particle on microscope, but it's only on not often. It's time to time, but основная main part not have dust in end of track.
Thank you.
Thank you, Bob.
Bob Greenyer, Martin Fleischmann Memorial Project. Spasiba, Oleksii, interesant doklad. Very, very interesting work. We warned a few years ago to the Russian community that it could be caused by three-body abrasion. So we focused on examples where we could see them on CCD sensors or inside the containers of ultrasonically treated fuel. And we have since reproduced all track types inside a plasma chamber and caught them on video and published those. However, your use of carbon is frankly genius because it's diamagnetic. And what I saw in your first slides with the large wide track is exactly how I would imagine the clusters colliding into the plastic that can be charged and then ploughing along the diamagnetic carbon in front of them. It's incredible to see. I don't know why I didn't think of that. Well done, you. Secondly, the lines where they are coalesced.
Sorry, one question after that, another, and too difficult.
Okay, so congratulations on the use of soot.
I understand first question and second.
Okay.
Thank you.
So in terms of the particles lined up, when a cluster breaks up, it releases its charge, and I would imagine it's charging those particles, and then they're aligning as they're coalescing. And then the third type of track, where you have a thin line on the outside and a fat line in the inside, I would suggest that is because of the toroidal structure. So very well done with this work. It's excellent work. Lastly, you can get positive, negative, and neutral clusters. So I can see how in the sealed chambers that you have inside the car, that you could get clusters going in and then producing tracks. So in the round, I'd very much like you to share that work as soon as possible and for me to have an opportunity to have a greater look at it. So thank you, absolute genius with using the graphite, the soot. So thank you very much.
Thank you, Bob. Next comment.
Thank you for your attention.
Please.
Hello, Kimmo Pyhtiä, University of Turku. Thank you for your presentation. And well, I have one simple question. Have you considered using CR39 as your detector to detect the particles themselves? Because then you can also get some information about the energy of the particles.
The question is, have you considered using the track detector CR39 as a means to pick up the tracks in order to discern their energy?
Sorry, but I don't have enough money for use difficult detectors. What need another.
That is a relatively simple detector. I think we could also arrange some to be sent as well. We have some extra.
So thank you for the question. Jacques, do you have something?
Yes,
thank you.
Congratulations again for your work. You mentioned that you have a sticking force of 1 gram of these particles. How do you define this 1 gram force? I don't really understand. What do you mean by 1 gram?
Then I give 2 discs and number it of dust part on them, and after that two discs together and slide them. So I use date, and after that I divide date what was on one disk on number of parts.
Okay, thank you. So Alan, the last, please.
I would just like to say thank you very much for what I think is a brilliant and inspired piece of work, and goes to show that you don't need a huge laboratory, you don't need a lot of fancy equipment to see something unlikely, something impossible, something possibly LENR. And from memory, by the way, I think CDs are made from CR39. They're all, so you have the material already, you just need to work out about etching. But brilliant work, and thank you. And this is something you could do in a high school, or with first-year university students. They love salt. Okay, thank you so much.
Yeah,
Thank you,
Alan.
for your attention.
Thank you for the wonderful presentation. We appreciate it. So our final